Well, here you see the opening banner, and it simply confirms that we're going to be looking at the September 2023 issue of the Bulletin. If I go to the next screen, you will see my email address bottom right. Please feel free to send your ideas, comments, and the best possible email you could send me is that, I would like to do the postscript next time, or an even better email is I'd like to take over running it. That would be wonderful. I can't ask for too much, but I certainly would welcome having some kind of backup. Meantime, I have just a word to say about the title of these events. You may remember last time I was talking about Sundial Zoom events, and Martins has correctly pointed out it's not a good idea to have a brand name in the title of one of your functions, because you never know when you might have to forego this, or something else will happen, and what have you. And so we thought about having Sundial Bulletin follow-ups as an alternative. That's going to mean two uses of the word Sundial are quite close together. So we ended up deciding that, at least for the moment, we will talk about Bulletin follow-ups, and that's what we're talking about now. So you'll see the banner on the left. Top, it says the British Sundial Society, then it says Bulletin follow-ups. Well, quite enough of the preliminaries. Here is the front cover of the September Bulletin, which I hope you all had arrived on your doormat safely. It shows the magnificently restored Melvin Sundial, restoration by David Brown, and I'm very much hoping he's going to be talking about this before we are done. Here is the abbreviated list of topics in the bulletin, the contents list. And as last time, there are a couple of things which I think we can eliminate. I'm not going to talk about the editorial, and I'm also not going to talk about the examination. This was an incredibly stiff examination that was set at the Exeter conference by Martin Jenkins. Nobody did very well, but very appropriately, our patron got the highest mark, and I refer, of course, to Fred Sawyer. So I'm going to eliminate those two things from the reckoning. And this is pure guesswork on my part, but I have a hunch that we'll be talking about those which I've just indented. Obviously, the lead article by Mario Arnaldi on the Erfurt Codex. And unfortunately, Mario is away at the moment. He's away from base in Ravenna. So he's handed this over to me, and I will do my best to serve as David Coffin did last time, introducing the lead article. Graham Stapleton, if he is here, will perhaps talk about a tiny bit about his floating point compass. And then later on, we certainly hope to have David Brown talking about the restored Sundial in the cover photograph. And then comes the article by one of our Norwegian members, Roar Hagendiers, who is writing about a Sundial compass. And final indentation is for the article John Davis wrote about a medallion, which has a sundial on the back. Since he wrote that article, he's got a tiny bit of extra news to tell us about. Well, more about that in due course. Well, I'm now going to unshare my screen, and Martins will instead show us the first useful page of the bulletin. And if you can see, if we can scroll down, well, first of all, you can see on the left two figures which are reproductions of manuscripts. And these are two surviving manuscripts, two of quite a number of surviving manuscripts of the Erfurt Codex, which is a description in words of how to lay out a sundial. And embedded in both, there is what at first glance looks like a drawing of the sort of plastic protractor you might find in a school geometry set. If you can look closely at the lower one in Fig 2, just going close there. Right, that's enough. Now you can see but it's not a protractor at all. It is actually a delineated sundial. Now, this is intriguing because you can see by the characteristically bunched up hour lines around the midday line and the spaced out lines around what we would call the 6-6 lines. And that looks very much like a direct south-facing vertical wall sundial. He hasn't labeled the hour lines, he's labeled the spaces between the hour lines. But look, the ones in the morning are labeled 7, 8, 9, 10, 11, 12, very, very clearly, could perfectly well serve on a modern sundial. Then after midday, he has 1, 2, 3, 4, 5, 6 in standard PM times, which are still used in North America and in England, though not so much on the continent. So we have here a perfectly satisfactory delineated vertical wall sundial. Now, it says, as you can see at the bottom there, this dates from 1433 to 1434. If you move to the right, we can see here the oldest known manuscript of this rule was made in Erfurt in Germany in 1364. So way older than what we've just been looking at. And even that's certainly not the original, because the rule was known in Germany in 1334. Now, just think about that. Here we have two manuscripts, or we have a rule with the associated diagram showing a perfectly well delineated vertical wall sundial for a polar-oriented gnomon. And the polar-oriented gnomon, as far as we know, wasn't invented until 1371. The oldest one known is in the Great Mosque of Damascus in Syria. And that was built and set out by the great Arab mathematician Ibn al-Shatir. So how come we've got these drawings of a vertical wall sundial requiring a polar-oriented gnomon 50 or 60 years before the first known polar-oriented gnomon? This is a real puzzle. Well, if we now go to the top right-hand corner of the next page, yes, the construction of the dial, worth reading this out. To construct a sundial, draw a semicircle and divide it into 90 equal parts. All right, he's deliberately going to cause confusion here. This guy has 180 degrees in a circle rather than the regular 360. And so you've got to double these numbers to get what we would think of as degrees, of which 5 degrees are contained in the space for the first hour. Now, you have to interpret that as 10 degrees. And when he says the first hour, he doesn't spell out what he means by the first hour. We'll see later, but he's definitely talking about unequal hours, but we're not going to go down there just yet. And it is as though whoever drew those diagrams, and they were drawn by two different hands, interpreted the first hour as being the first hour of the afternoon. And then it says from the 5-degree end, draw a line up to the center of a semicircle, and the second hour will contain 5 degrees and 30 minutes, by which he means 11 degrees in the way we think. Altogether, he's talking about 6 angles, and these angles are 10 degrees, 11 degrees, 13, 12, 16, 18, and 22, which I assure you add up to 90. But whoever's drawn them out has drawn them out from the midday line incorrectly compared with what the text is going to tell us. And it just happens that works beautifully for a not yet invented vertical wall sundial. Now, if you come down to the bottom, you will see lines 15 to 20, it says true south must be determined in the following way. Well, if you were lucky enough to come to the Newbury meeting, you will have seen Jeff Thurston described precisely this method. He tried it out for real, and you saw his results. This is a well-known way of finding true south. And then at the very bottom, it says, be aware that the dial determines the artificial day, which has 12 equal parts from sunrise to sunset. But he really is there spelling out that this is a sundial which is talking about unequal hours. And so the diagram is just there to confuse us. What he's actually doing, in retrospect, it turns out, he is if we go to the next page, we can sort of see this. Right, there at the top is how the person should have drawn out the protractor. You see, starting at the first hour, we again have what he's written as 5, 5.5, which I interpret as 10, 11, and so on. So now we have the hour lines spaced out around midday and bunching up towards sunrise and sunset. Absolutely not what you would expect, and indeed what you don't have on a standard modern vertical direct south facing wall dial. Now, if we go down to Fig 5, we see, pause there, the fat lines show the traditional, if I can call it that, way of marking out an unequal hour sundial. You have a gnomon perpendicular to the wall, which he doesn't say specifically, but it is perpendicular to the wall. And you then have these lines at 15-degree intervals. And although the two horizon lines and the vertical midday line are correct, all the other lines are wrong to some extent, depending on latitude, unless you happen to be spot on the equator. And what this guy is doing is saying, I can do better than that if we bunch them up a bit towards the horizon line. So go back to the top, and that top left, yes, if you close in on Fig 3, you'll see what he intended by the words, and we get a sundial, which I'll demonstrate shortly, is a great deal better than the traditional 15-degree line one. So we have got here an improvement, and these lines he's worked out are correct at the equinoxes, and then not as bad as the 15-degree lines at other times of year. Now, Mario's comment, we're now moving to the right-hand side, but the suggested there, very top of this left-hand column, stop. But the suggested method, in addition to having poor mnemonic value, now that's not Mario writing there. I detect very much the hand or the text of the late great Gianni Ferrari here, because I had lots of conversation with Gianni Ferrari about unequal hours, and he didn't like the Earth rule at all. He thought it didn't make mnemonic sense. If it wasn't mathematically sound, then it's not good enough for him. And I feel Gianni gets an acknowledgement towards the end, and I'm pretty certain that Mario thoroughly agreed, and not unreasonably, with what Gianni said. But my own personal view is that an improvement is better than leaving things as they were. And I'll show you later how much of an improvement this was. Now, at the very bottom of what you see on your screen, it talks about the reform of a rule. And this is a ridiculous sort of retrofitting of a rule to a polar-oriented sundial. And now if we look at the bottom of the page, the construction of the dial, this is a modified rule. To construct a sundial, draw a semicircle, same start as before. The space, now it says, not the space of the first hour, the space of the first hour afternoon contains 5 degrees. So he's spelling out in the modified version that we're talking about a 5-degree spacing afternoon, as the original sort of protractor-like things were. But now we're talking 300 years later. This is, no, 200 years later. This is 15th century, by which time, even in sort of backward places like Western Europe, we started to know about the polar-oriented sundial. And so the rule is now modified for polar-oriented sundial, exactly the same degrees, but now we really should start at midday. And if you look, that's table 4, and this is where, yes, that's as far as I'm going to take the article. And now I'm going to share the screen. So Martins, if you can stop, and then I share screen. And I'm going to tell you why we have this extraordinary coincidence. So why is it not doing it? Here it is. Right, this is me back on. And I go down. Right, the airport rule. Just let me get rid of the stuff on the side so I can see what I'm doing. Right, let us start with a wall. And this is, wait a minute. Why is it doing that? Yes, here is this grey thing is a cross-section of a perfectly ordinary wall. And this is a cross-section, north on the left, south on the right. And we have a horizontal gnomon perpendicular to the face of the wall. So that's a line true north-south. Absolute traditional gnomon for a unequal hours sundial. And what the Earthort rule, the original Earthort rule, did was simply to see where the shadows of this line were at an equinox and say, all right, we can't do a really good job, but this is better than what went before, better than the 15-degree version. And then the modified Earthort rule shows that exactly the same lines work for a polar-oriented gnomon, which I've now added to this. So we've got two gnomons in one. This is what I would call a double vertical sundial, but John Davis doesn't like it at all if I say that. So I will keep quiet about that particular suggestion. And I'm further going to black it in. So we've really got two gnomons in one here. And I'm going to add one more line, a broken line, whose length is K. This is the only dimension I'm going to be using. Now, this is essentially a shadow line from the tip of a gnomon at a special case of a special case. So this is at noon when the declination is 0. So noon on the day of an equinox, equinoctial noon. And that line is then in the equatorial plane. And on the day when we have an equinox, we can assume the sun goes around the sky in a disk rather than in a cone. And so the disk intersects the wall in a straight line, which of course is the equinoctial line. Let's have a look at the profile. Sorry, that was the profile. Let's have a look at elevation of this wall. I'm just going to draw the elevation of the gnomon and the noon shadow on the day of an equinox. And I'm going to mark a whole lot of points on the dial. But the first point is where the tip of the shadow of the tip of a gnomon is on the day of an equinox. That's not a very interesting shadow. So let's have a look at the shadow of this gnomon 3 hours earlier. Now, this is an unambiguous meaning of an hour. We're talking about a day of an equinox when an unequal hour equals an equal hour. It's both 60 modern minutes, approximately. And again, I've marked a tip, marked a blob at the tip. And you can see these two dots so far in a straight line. This is an embryonic equinoctial line, and astute members of the audience will notice that the separation of these two dots is exactly the length K. Strictly speaking, the line K and the line between these two dots define a plane, and K is at right angles to the line. The dotted line is at right angles to the line between these two dots. And strictly speaking, the separation is K tan 45, 3 hours before midday. Well, tan 45 is 1, so this matches K. In between, we've got two more dots, which we'll see later, K tan 15, K tan 30. Now, I'm now going to mark in a whole lot more dots. And the extreme one on the left is 5 hours before noon, and the extreme one on the right is 5 hours after noon. Unfortunately, my screen isn't wide enough to show you 6 hours either side because those dots are at infinity. But I can show you the shadow at sunrise. So remember, this is direct south facing. It's on the day of an equinox, so the sun is due east, that's to the right, and it's on the horizon. So the shadows of both gnomons are horizontal, and they meet at infinity where the relevant dot is. Now, I could be marking out both sorts of rule, but I'm going to start with the original Earthort rule and show you the shadow of the horizontal element of a gnomon. So there it is. I just draw a little bit. I run out of paint to draw to infinity. Now, leaving that first hour line in place, I let the shadow run for an hour. And here we are, 1 hour after sunrise. And I'm going to mark in a second hour line, marking 1 hour after sunrise. So these are the first two lines on the Earthort improved unequal hours design. Now, here we are 2 hours after sunrise, and I've marked the line. 3 hours, 4 hours, 5 hours, and of course 6 hours after sunrise takes us to midday. And this is the Erfurt rule as described in the original 14th century text, but not as drawn on those sort of school protractors. So we have lines close together around sunrise, spread apart around midday. And I think this is how Mr. Erfurt, or the Erfurt's a place. I keep saying Mr. Erfurt. How whoever designed the Erfurt rule, I feel he must have drawn these dots because it's ever so easy to draw these dots graphically, and then therefore very easy to draw the lines like this. And within the precision of those diagrams, this is how this is right. For 48 degrees, I should point out that the gnomon is for 48 degrees north. Now, I could carry on in the afternoon. I just get the mirror image, but instead, I'm going to start at the end of the day, sunset, when the dot is at infinity the other side. But now I'm going to mark out where the shadow of the polar-oriented gnomon is. So we have what, of course, corresponds to the 6 o'clock hour line as an equinox. But it will also work at 6 o'clock any other day of the year, provided the sun is shining on the dial. Come back an hour, 5 o'clock in the afternoon, marking the line, 4 o'clock, 3 o'clock, 2 o'clock, 1 o'clock, and midday. And you'll see you've got exactly the same angles as before, but rotated 90 degrees. And this seems quite miraculous. And I'm going to shift this sideways and remove the dots. And now I'm going to use some magic scissors to cut the new set of lines off from the old set, like that, and rotate. And you've got exactly the original thing. And it really does turn out that if the Erfurt rule for an unequal hour sundial gives you exactly the right lines for a modern day sundial at the same latitude, just you have to do this subtle bit of rotation. Now, I said I had skin in this game, and I'm now going to show you, well, the obvious, and address the obvious question: how good is the Erfurt rule for times other than at an equinox? And can we do better? The answer is it's pretty good, and yes, we can do better still. And I refer you to the Margaret Stanier Memorial Sundial. This is on the wall of the Rosalind Franklin building at Newnham College in Cambridge. Rosalind Franklin was one of a team of Crick and Watson who discovered DNA, or the structure of DNA, and they she didn't get a Nobel Prize, they did. And this is not because the Nobel Prize Committee were misogynist, but that's because she was already sadly dead at that time. She died very young. Well, Margaret Stanier will be familiar to some of you. She was the editor before our current editor, and she died in, I think, 2009. And she was a fellow of Newnham College. As an aside, I should say that our de facto editor now, Christine Northeast, is also an alumna of Newnham College. So it is very appropriate that we should have linkage with the British Sundial Society and the Erfurt rule, about which more right now. Here is a traditional 15-degree sundial. You have a direct south-facing wall with a circle marked off. You have a gnomon, which is horizontal, and a line north-south. And we draw lines at 15 degrees. And all of these lines are frankly wrong, except for the sunrise-sunset lines and the midday line. Well, I'm not going to go through all of them, but I will restrict this to just these 5 lines because the mid-morning and mid-afternoon lines have meaning in religion, because they are for the Christian offices terse and known. So they were quite important. Sorry, terse, and yes, I do mean that. The 3rd hour and the 9th hour. But while the 2 horizontal and the 1 vertical line are correct, these 45-degree lines are not correct. Where should they be? The answer is there's no right answer. You can imagine going out at mid-morning using your high-tech kit to know when mid-morning is. And every day of the year, 365 times, you draw the shadow at midday. And you'll get a spread of values looking like this at midday with a mirror image on the other side for mid-afternoon. And it's so far out that the 45-degree line isn't anywhere in this whole band of spread out shadow. It's completely useless. So let's get rid of it. Question, though, is where should we put it? And here, without wishing to go too much detail, there is a bit of a choice. An obvious place to put it is in the middle, but halfway between the two extremes. Well, mathematically speaking, those extremes are known as outliers, and serious statisticians get the heebie-jeebies if you suggest that you do any statistics based on outliers. So we reject putting it in the middle as not a good idea. Two more serious statistics, which we know about, are the median and the mean. And the Earthort rule uses none of the above. It says, well, let's have a line where it is at an equinox. And you might think, well, wait a minute, the equinox is halfway between the two the solstices. Why can't we use the Earthort rule and have the equinoctial line? It must surely be halfway. Unfortunately, it isn't, because although it's halfway in declination, it's not halfway in time. And when I was discussing this in this design 14 years ago with both Gianni Ferrari and, more importantly in this context, Jeff Thurston, he pointed out correctly that because the sun is more often or spends more of the year in the summer half of the year than the winter half of the year, the equinoctial position is biased away from the best possible position, which is the mean. So you can do very fractionally better than Earthort, but be quite honest, the difference between the mean and the equinoctial position is very, very small fraction of a degree, and nobody would notice. But if you're pedantic, you can put it in either place, and it really makes no difference. The mean is slightly better. Can we do better? We could obviously put the line in that grey area, but we've still got this huge spread. Can we reduce the spread? Well, yes, you can. And I'm going to ask you to watch carefully. I'm going to dip the gnome on, and several things are going to happen at once. We're going to improve the spread of these lines, or at least reduce the spread of the two mid-morning and mid-afternoon lines, and we're going to degrade the horizon line. So just by dipping the gnome on a bit more, now we're getting pretty good. We dip any more, we start getting worse again, and a lot worse. So you find the sweet spot, which is here, where actually the spread is less than the thickness of the surviving midday hour line. We have degraded, unfortunately, the horizon line, but on this particular sundial, there are so many trees and buildings in the way, it's never going to get a shadow at sunrise or sunset. So I simply solved the problem by not having an horizon line of any sort, neither sunrise or sunset. And you'll see on the left, I've got this wiggly line for sunrise ending in an upward flick, time to get up, and this one ending in a downward flick at sunset, time to go to bed. Right, well, that's sort of what I did. And here you can see the before and after. This is with a horizontal gnome on, and you can see the spreads of the first, second, third, fourth, and fifth hours, and they practically overlap with each other. And there's a particularly bad spread for the mid-morning, which is what we're interested in. By dipping the gnome on, we can get to the sweet spot. We can get really good values at 3 o'clock, well, mid-morning and mid-afternoon. And we're not too bad most of the rest of the time. Certainly we're better than everywhere on the unmodified. So if you like to think of this, what I did with the Newnham dial, this is a modified Earthort rule. And I think that's almost enough, except to show you the final thing of what I did. And I'm now going to unshare my screen again and back to Martin's for the next bit, which is you can come back with the bulletin. And where we have the compass. Now, do we have Graham Stapleton with us? Is he on the list of participants? If he isn't, all I need to say You see, there's too much of me. I should have had Mario. I should have had Graham. You can see the whole thing is floating.
We have Graham.
Right?
I'm just not sure whether the same Graham. Graham, please
Graham Stapleton.
switch on the mic.
Hello, Graham. No. All you need note is that there's a sharp compass point, with the whole thing is balancing on a compass needle, and the whole thing floats and will find itself pointing to north so that you can read the compass directly. You go on to the next article. I don't think we need to say anything about the postcard. Right, you can go back to that one. If you've noticed, this is a picture of me and my favourite one of my stone cutters, Lida Lopez Cardozo Kindersley. She got an honorary degree, and I went to the honorary degree ceremony and I had a part in it. And that's what we look like in academic dress. And on the right, you can see what we look like when we're playing with sundials.
We have raised hand from Kevin. Kevin, please.
All right, let's have Kevin.
You can ask, comment something.
Can you hear me?
Yes.
Yes.
It's just to go back to the previous article.
Yes.
It's named the last floating compass, I think, if I remember rightly, but it's not. I've got a more modern version to show you.
If we stop sharing,
I don't know if you. I don't quite know how to get.
Yes. Just hold it up. Hold it up. That's the thing. Yep.
This is a floating dial compass made in France. What? It's made in France. It's designed by somebody with a very strange name called Bernard Vorenessen, and it's not floating at the moment, but it floats like that. It's got a compass which aligns it to north. You can set the variation in north with the magnetic north, and you can read the time. The problem with this, it's very old, and the gnomon, in fact, is bent. The plastic is and the whole thing is very much falling to pieces because the black plastic has decayed a lot. If anybody thinks it's worthwhile, I'm perfectly happy to write a little article about this in the bulletin. It's a nice little piece. I've looked up the people who are meant to have who designed it, and all I can find out about them is that the husband and wife, they're French, but they were, I think, working in Italy, and they were sort of garden designers, and the husband was an engineer, and this seems to be a thing that was made by the husband. That's all I have to say.
Right, wait a minute. Somebody else got a hand up. Who's this?
Woody, please.
No,
Doug Bateman. Yes, Doug.
I have just submitted an article to the bulletin about this floating sundial. I've been in close contact with the designer, Bernard van Essen, and with contact in Germany, Michael Promack, and lots of information has come forward, and we hope to have a little piece in the bulletin in due course. I've sent a draft to the editor, but I haven't heard anything back yet.
No, you haven't heard anything from me. The editor was not. I was afraid I was engaged in too many other activities, but we've got it. We're looking at it, and we'll progress it.
There's another comment from Woody, please.
Right. I was just going to try to find my copy of the same one that Kevin has there. And the basic design problem is that the gnomon begins to melt in the sun. And so that's why it gets bent.
Designed by Icarus.
Right.
And then we have Graham.
Yes, hello. Right.
Hello. Yeah.
Now, I'll try and get. There is a request to see the item live and moving.
Yes.
Just rather difficult to manipulate it to the camera.
Yes, it's visible.
Right. Now, if at the moment it's held down by friction, if you press the pin underneath,
it really does float.
Sorry.
Yeah, hold it up a bit. Yep.
Yeah, I've got to have the screen at a terrible angle. I say it is completely free spinning and thereby self-orientating.
You leave it alone, will you?
I can show you another one, because this, if people can see, is a horizontal. This one that's come to me to look after is actually an azimuthal dial, which I've no idea if you can see it, because I can barely see it on my own screen. But with this one, it's necessary to align the case, and then the dial sets itself magnetically. Right. That being all I have to say, apart from any questions.
Thank you. Yeah,
Thank you very much, Graham. Much appreciated. I just wanted people to see that it really does float, and it quite clearly does. Martin's back to you with wherever we've got to. Yes, next page, please. Next page. Right, we've now got the rest. I think we can ignore the photographs. We have the restoration of the Melvin Sundial. And now, if you unshare, we'll go to David. So this is our photograph. Our cover.
Yes, I'm here. Can you hear me?
Yes.
Are we on?
Are we on?
Are we in contact? Are we in touch?
Yes.
Okay, I'll carry on. Thank you very much for giving me this chance to talk about the Melvin Sundial restoration. The one that is illustrated in the article was, by all accounts, quite straightforward. And those of you that may have tried doing any lettering on slate would appreciate that the very, very fine lines and curves and twists of copperplate handwriting are really not suited to the traditional way of cutting letters in stone. Those of you that are familiar with letter cutting would know that the tools that are used
article by article, and make any comments.
Can you switch him off? Yep. Carry on, David. Yes.
Yes, okay. The traditional tools are with a dummy and a chisel, and you need a fair bit of effort to get it through a hard bit of stone. The size of the chisel is dictated really by the size of the letter that you're cutting. So that on this example, for instance, I'm not sure whether you can see that.
Yes.
On the right-hand side, the letter S is V cut, and the width of the letters dictate that the size of the chisel should be about the same, and that was used for cutting this V cut letter. But the smaller the letter, the smaller the chisel. These letters here are incised around the edges with a very small chisel, and by small I mean one that would be about, I don't think you can see that one, there we are, that's a 4mm chisel, and again in slate of this kind it would still need to have the dummy to be able to penetrate to the depth that you need it. However, with the Melvin dials, a much finer chisel is required, and to recover the letters on a Melvin dial, I've found it necessary really to use a scribe to impress the shape of the letter, the curve or whatever, which then gives a guide for the chisel that is going to be used to make them a little bit wider and more clearly read. I also use, you can probably see it here, a pair of magnifying glass headset so that I can see what I'm doing with comfort. I have a sloping board so that all the dust falls away, and a good illumination, so we'll turn on the lights, and then we can pick out the lines that need to be emphasized. In this case, with the scribe, we're pulling it like so, very carefully. It's a two-handed job because you need to have enough strength in one hand to pull the chisel and the other one to steady it to make sure it doesn't slip. So we get that. Then the small chisel that I need is a 4mm one started off as, but I've shaved the edges so that it then becomes a 2mm chisel. And because it's such a narrow shaft, I've put this masking tape around the end. So I've got something for to push against to force the chisel along the line I need. So that would be operated on something like this. Just get my goggles in place and we just get that in the groove, and then gradually, I won't go very far with that. You can see that the line, I hope you can see that the line is widening, and it's all under control, all very slow and precise. Now, if the dial, when it's all been restored like that, is just left like that, then dirt will accumulate in there. If it gets wet, everything more or less disappears. These letters have been painted with just ordinary Humbrol enamel. There's little tins of Humbrol enamel that you can buy in the hobby shops, but wet those and it gives a very nice contrast to the places where the letters have been cut. And the other thing is, of course, that in order to get the paint in there, you can't be terribly precise about where the paint goes. So it's all sloshed in, and then when the paint is dry, rubbed down with diamond pads until you come back to stuff. And it shows then up other cracks that scratches that may not have been seen in the first instance. So those in turn will need to be rubbed down and then possibly more painting. It is a long process and a patient one, and it on and off for 2 months, chiseling away at the little details. Now, as it happens, quite by chance, Masha Lose, who's got an article later in the bulletin, contacted me and said he very much appreciated the article on the restoration of the Melville dial. He said he'd got a Melville dial and could I restore that for him? Well, he posted it very quickly and came up with this item. This particular one, you can just about see it there. This particular one was made earlier than the one in the article and is dated 1842 as opposed to 1850 something on the article one. And moreover, his name on this one is Richard Melville, double L-E at the end, not an N, which it is well known that he changed his lettering there for some reason. Now, one of the details about this is that round here, round this edge here, I'm not sure whether you can, yes, round this edge up here are the equation of time correction information, January, February, March, April, May, June. And underneath that, it says here, sun to fast subtract. Whereas on the restored one in the book, it says dial to slow add. So he changed his technique quite a bit. And in between there, I can barely read the details on here, but I'm going to have to work on that and see what exactly they say. But there's a lot of fine detail and little extra decorations all over the place. So that's my wintertime occupation, amongst other things. And I'll leave it at that. Thank you very much.
Thank you. Anyone else have questions?
Oh, just one other small detail I'd like to point out, that this particular dial has got gnomons which have got a very fancy recessed edge here, which I've not seen on a Melville dial before. So that's an interesting little detail. Yes, I'll take questions if there are any.
So far, there are no raised hands. And possibly Maciek could give some additional comments on this particular dial.
Do you hear me?
Yes.
Yes.
So first, thank you to David for accepting this commission and the hard work for you. I'm sorry for.
So it's all good fun, really.
This is the interesting history of this dial because I bought it at eBay some 12 years ago from another member of British Sundial Society, Mr. Harley from Ireland. When it was offered on eBay, it was covered with talc, and it looked beautifully. Also, there were some photos of it in the raking sun, and which under which the engraving looked much deeper than it turned out. And when I got the dial, it looked really impressive, but I realized that it actually required some serious restoration work, and wondered if it is technically possible to re-engrave such a finely engraved dial. To make lettering more visible and clear. And it was only after 10 years that I saw this article by David and realized that actually it's technically possible. And I hope that after David's work, it will look as nicely as the one Melville Dial photograph in the bulletin.
Yeah, fingers crossed then.
Yeah.
Right, Martin, it's back to you.
So, yes, no more raised hands. Thank you. Thank you, David, for the virtual visit to
You're
your
welcome.
workshop and insights into different techniques of letter carving. Okay, I'll share my screen again. We are switching to next article. On, it's on.
Yes. Now we come to Royal Hagendis. This is the Labylont Sundial Compass, and I had lots of discussions with Roar over this, and joined by even more entertainment when once Sue Manston joined in. And there's quite a lot to say about this, but I think I'm going to leave this one to the postscript. And so we'll bypass this one for the moment, unless anybody's got some immediate questions, and we'll move on to the next thing, which is this portable dial or portable dial puzzle by John Davis. If John is there, can you see John in the list?
Checking by name. It seems John has not joined the call.
Right. So all these people are too nervous to speak, so I'm going to have to speak for him. All he wanted to say is that since the article was written, he's come across several more of these medallions. I mean, obviously the face on the main side is what's really important. The sundial is to the medallion holder is not so important, but there are plenty of them about there. But this is by no means the only one found. So on to the next. We can bypass the examination. Right, yeah, you've gone too far.
Yep.
There's Maciek's article. Now we know that Maciek's there. Are you going to tell us about this? Has he disappeared?
It
Okay, I'm back.
You're back.
Actually, I cannot tell more than what you see, what you read in the bulletin. I'm not an expert in ancient sundials, but actually, what was really shocked me was the small size of both sundials at the exposition in the Grandmaster museum, and the concept of a double sundial, which I associated with 18th century or early 17th century Augsburg sundials, and it was quite interesting for me to see that some ideas, a similar idea appeared 2000 years earlier. And generally, it's very interesting that some such ideas independently reappear in relation to gnomonics. For example, you also proposed last year or 2 years ago a double stereographic sundial, as far as I remember, which was based on this same principle.
Yes, thanks so much. I can add a little bit. The thumbnail shown as figure in the A figure, top right. This is relatively unusual. There are very few like this in Sharon Gibbs, and it's clearly got a modern, completely out of place gnomon on the left, which you can forget about. It should have two gnomons, and the one it's got is clearly missing. Is clearly not misplaced. Now, the figure you see with some curious hairstyle, if that's what it is at the top of his or her head, with outstretched arms, that's the vertical face of the ornament, if you like to think of it like that. And if you consider the top right-hand side, so you've got, yes, if you can point to the very top of the figure, the midpoint at the top, yeah, there, and trace the curve down to the right. Go down and to the right. Right, now look at figure B. So just zoom out a bit, yes. And again, trace from the top left-hand corner of figure B and trace down and to the right. And those are essentially mathematically identical shapes, or mnemonically equivalent. And in both cases, there is a missing gnomon, which in the case of B should be at the top right-hand corner. Now, clearly, in the case of B, there is a right-hand half which is missing. But if you think in terms of the missing right-hand half of B, and you plonk it on the left-hand side of the existing B, what you get is not totally unlike the top half of what you see in A. There must be a word for this sort, but I think there are only about 4, even in the whole of Sharon Gibbs. As it happens, one surviving sundial, much better condition than this, which has this sort of double arrangement, which clearly needs two gnomons, is owned by the Fitzwilliam Museum in Cambridge. And I have seen it both in the Fitzwilliam Museum, but it's not there now. It's currently on display in the Whipple Museum in Cambridge. So if you want to see a better version of this, come and have a look at the Whipple Museum in Cambridge, and I'll take you out to coffee. But it's unfortunately not my favorite design of. I much prefer the hemispherical sundials. So enough of that. Let's go on. I think it's that the last article. What happens after that? Yes, then the Zoom event. We need to talk about that, and that brings us, I think, to the end. Right now, we come to the postscript where I go back. So if you stop zooming and I stop sharing screen,
yeah.
and I start sharing screen, back to this. And now I think I know what to do. Right, this is for postscript. Those of you who've had enough, feel free to leave, and I will then indulge myself by telling you about my ideas for this rather curious instrument. When I first read this article, I suppose through force of habit for 40 years of being an examiner of one kind or another, my immediate thought was, oh, this looks like an answer to an examination question. So I invented an appropriate examination question. You assume that the sun is shining and that you have with you a magnetic compass. And the question is, how can you determine the time of day? Now, those of us who were in the business of setting examination questions would deem this to be thoroughly so-called ill-conditioned. It has nothing to say about the location, latitude and longitude, nothing to say about the time of year, and more importantly, so you don't know about the declination, and it doesn't draw attention to the fact that magnetic compass might have its own local magnetic declination to contend with. As for the question itself, this is completely impossible to interpret. What on earth does he mean by the time of day? Now, I can say something like that to this particular audience. To an ordinary person, the time of day is obvious. It's what you see on your cell phone, your mobile phone. That's the time of day, definitively. And it's probably what Kevin Carney would deem to be the time of day. But we all know as Sundial people that the time of day as a concept has had all kinds of meanings over the centuries. And it's not clear here what is going on. But, I then thought, really all you can do with a compass is tell you the solar azimuth. That's just about all the information you can get about the sun from a regular compass. And unfortunately, solar azimuth, the direction or bearing of the sun, is not what we want. What we want is the solar hour angle. But then I suddenly had a brainstorm, and I lost my whole train of thoughts for a moment, because I suddenly realized that this is not necessarily the case. Do we want solar hour angle? What I had suddenly remembered is that Lavi Lund was, of course, Norwegian. Moreover, Roar Hagendaes is also Norwegian. I suddenly thought maybe sort of deeply buried in the genes of these two gentlemen, they were harking back to their distant ancestry in ancient Scandinavia, where the people of the time really did use solar azimuth to partition their days. So I instantly had a wacky design of compass. Here it is. And you'll see that this is strongly based on the Lavi Lund. This is straight plagiarism. And I have a fixed dial. This is not like the floating dial that Graham Stapleton showed us. And it's got a fixed compass card. The compass card is fixed to the case. But the needle, of course, points to magnetic north. And from now on, I'm going to assume that local magnetic declination is 0, just because I don't want to have to say, oh, now take magnetic declination into account. Let's just pretend that magnetic north and true north coincide. You will see that I've arranged this compass drawing to match the orientation in the photograph on the left. So the needle points in the same direction, and the N for north and the compass card does too. Now I imagine going into a time machine and going back 1,000 years or so to ancient Scandinavia and trying to sell this design to the locals of the day. And I would explain that the compass has magic properties, that this needle points to true north, and what they would think of as Mivnieti. If you were with me in July, remember this is the Old Norse for middle of the night. And so they're referring to where the sun is in the middle of the night, which of course in Norway, certainly if you're far enough north, you really can see the sun in the middle of the night in summer. And even further south in Norway, you can see a glow in the sky at the north. And I then demonstrate that if you rotate the dial, you can rotate it and shake it about. No matter what you do, the needle has a mind of its own. It points to the middle of Mivnieti. It points north. And if you then have a special case, you rotate the case so the two ends line up, then the 8 radial lines which I've incorporated into the design precisely delimit the 8 segments of the horizon, which they call ether. And I'll even write the names, just in case you've forgotten the names from the July postscript. And we have middag for midday, and so on. And that the locals of the time would thoroughly understand the utility of this instrument, and they would instantly see that you no longer need to identify 8 mountains and be in a fixed position so as to see where the sun is with reference to these mountains. You can take this compass around with you. All you have to do is put it on level ground, align the two ends, and then you see where the sun is, and you can align with the partitions, which I've marked on the dial, and you can tell what the time of day is in the way you were thinking 1,000 years ago. Let me mark in a north pointer, and I'm now regarding this as a diagram. And when I have diagrams, I really do find it much easier to understand if the north pointer is up the page. So I'm just rotating the diagram like that. And now I'm going to remove the Old Norse words, come back to the present day, and show you 2 standard ways of finding the azimuth of something on a compass. Now, in children's textbooks, the typical object is a church tower or possibly a lighthouse or something, but there's no reason why you can't find the azimuth of the sun. But let's suppose we have a church tower over on the top right. And one way of finding the azimuth of that church tower is, again, to align the N on the card with the N on the needle. And then you mentally draw a line from the center of the compass, that black spot, to the church tower, and see where that line intersects the labels on the rim. And if that line goes between the N and the E, right, means that's northeast. And if you want to put a number to this, well, let's incorporate a degree scale. And if you look on the photograph, you will see that this is exactly how Labilund has it. With my pointer, I can identify the N for north. And just underneath that N, there is a tiny circle, which is the 0 of his 0 to 360 degree scale, which you'll notice goes around clockwise as it does in my diagram. Obviously, the church tower is halfway between 30 and 60, 45 degrees, or as navigators would say, 045 degrees is the bearing relative to true north. But that's not how most people use a compass for finding the bearing of an object. What they normally do, if you've got an upmarket compass, is to use a pair of sights. Well, neither the Labilund compass nor my compass is upmarket enough to have sights, but I have got a little red dot, the circumference of the rim, and that corresponds in some sense to his red dot, though nothing like as pretty. And what people do is they rotate the, well, in this case, the red dot, the outer sight, so that the line from the center of the compass, the black spot through the red spot, aligns with your target. That's what you normally do, but of course the needle now indicates northwest, which is not the direction of the church tower in this case. And it's not 315 degrees either, so this just isn't terribly helpful. What my own upmarket compass has on it is a degree scale, but it goes around anti-clockwise precisely to deal with this circumstance. So here is the same degree scale, but flipped. And the needle now says 45 degrees, and we just ignore the northwest. Now, I simply do not understand. This is my first gripe about the Labilund compass, is why he has a degree scale going around clockwise when his hour scale, which you can just about read on the bottom, you see 12, 1, 2, 3, 4, goes around anti-clockwise, which you would expect given the way he's using the compass. So if I were marketing this compass, I would have had the degree scale going around the other way. In fairness to the Labilund, it rather looks as though he made no new use of the degree scale at all. But I certainly want to make use of a degree scale. And that means somehow we've got to have a way, if we're marketing this to the general populace, of explaining how you take the azimuth of the sun. Let's suppose the sun is at 45 degrees, which you can certainly be early morning in Norway. How do you translate that into the time of day? Well, there are 2 ways of doing this. Get the hour angle from the azimuth. You can either provide some tables, which is essentially what Labilund does. He has the tables on the back of his instrument, or you can provide graphs. And I want to show you how we can make progress with a graph. So here is a sort of blank graph paper. And along the bottom, I've got an azimuth scale, which is duplicated at the top. going northeast, southwest, and back to north again. So I go around all 360 degrees, and I've got north. I've got north to 360 as well. So you can have it either way you like. Up the side, I've got hour angle measured in just hours, 6 hour intervals from midnight, naught hours, beginning of the day, midnight, the end of the day. And in some sense, both the left-hand margin and the right-hand margin should be wrapped around as a sort of cylinder, but also the top and bottom should be wrapped together. This is really an opened out torus, but you can ignore that. Just think of it as a square because that's what it looks like. Okay, now if we're going to have an example, we need to consider where we are. We're in Norway, and let's suppose that you're planning a holiday in Norway next year on the 20th of March. You may go a few days early and a few days later, come back a few days later, but centered on the 20th of March, which of course is the spring equinox, the vernal equinox next year. So we can immediately mark in 2 dots. We know the sun rises 6 o'clock in the morning due east and sets at 18 hours at 6 o'clock in the afternoon due west. And because it's the equinox, I'm going to assume the declination is 0 all day. We can't actually do any more unless we know whether this is the northern or southern hemisphere. Well, clearly it's the northern hemisphere. So I can, with the latitude, draw a precise curve between those 2 spots. And here it is. It's very nearly a straight line, but clearly not quite. So time in Norway and azimuth are pretty linearly related at an equinox. And as far as I'm concerned, this is all I would need if I were to go to Norway for a short break next March on the 20th. But if you are Kevin Carney, or for that matter, you are Labi Lund, you insist on dealing with the equation of time too. Well, on the 20th of March next year, it's about 7 minutes. Now, watch very carefully this curve, and 7 minutes makes a fractional difference, but you can just detect it. Well, I don't mind people taking into account the equation of time, but this is supposed to be a portable instrument, and Labi Lund also takes into account the longitude offset from the reference meridian, which pretty well tells you the time, the local apparent time in Stockholm, 15 degrees to the east. And for some very curious reason, he takes his reference longitude for his compass to be 8 3/4 degrees east, which is 6 1/4 degrees short of the reference meridian for Scandinavia, Scandinavian standard time in the winter months. Well, 6 1/4 degrees translates into 25 minutes. So Labi Lund offset the whole curve by another 25 minutes, making 32 minutes altogether, and that does start to show. Now, I have very good reasons, as seen by me, you don't have to agree with me, for not taking either the equation of time into account or the longitude, because if you're using this for hiking, what's much more important to you is not this time in Stockholm. That's no interest whatsoever. What you really want to know is how far you've got before sunset. And we can see why this is important if you decide to have a rather longer break in Norway and you're going to be there all the way up to the summer solstice. Let's add a second curve. And between due east and due west, it's not that far distant from the equinoctial curve, but it does stretch a great deal further towards the north, both in the early morning and the late afternoon. And you could treat the equinoctial line as your reference and simply use that and forget about the difference offset. At sunrise and equally at sunset, the summer solstice curve is just about an hour different. Well, you could study this and learn from it and say, okay, I will add an hour in the morning at sunrise and subtract it in the evening, and then just each hour or each 15 degrees I would add 10 minutes less and so on. So you could linearly interpolate. And remember, this is the extreme case. What's much more serious is that you wouldn't be able to say anything about the period between sunrise and the sun being due east, simply because your reference curve doesn't extend that far. Let's suppose you have a whole year in Norway and we go to the winter solstice as well. And you can see that between east and west, these three curves, they certainly don't overlap, but then they're quite close. The thing that's really dramatic is the change in sunset time, or sunrise time on the left and sunset times on the east. And if you really are hiking around in the wilds of Norway, and there are very, very long stretches of wilderness in Norway, what you want to know is how much time you've got before the sunset, so you can pack up or open up your tent and set up your tent and your belongings for sweating out the night, perhaps in the depths of winter when the temperature can drop to -30 or -40. So the way I would sell this instrument would be to cut out this blue line, this long thin rectangle, and have this as a wristband, which you can see clearly on your sleeve. And the nice ratio is this is just about right for a fat anorak in very cold temperatures. I'd have far more grid lines than I've got here, but this is the beginning of a design. And it would mean that from your compass bearing, you could see how much azimuth you've got before sunset, which is all important. Well, let's now think about the time before sunrise and after sunset. I'm going to put in these broken lines, which take me literally from midnight to midnight and north all the way back to north again. And it's instructive to see what these three lines look like at different latitudes. Now here we're clearly looking at 60 degrees north. Before I do that, here we have 7 declination lines, as you've never seen before. So this is what Labilont more or less takes into account. He's got 7 lines. Actually, he's got times that are very peculiar. Let me put in he's got 7, 9, 11. He also has 12, which I'm omitting, 1, 3, and 5. He identifies those as special spots, admittedly not on the equinoctial line, but that's by the by. And he then flattens that to a curve, well, to a straight line, which I'm reproducing here. In short, he's using as a measurement of azimuth the times 7, 9, 11, 1, 3, and 5 on the 15th of April. All I'm doing is exactly the same idea, but translated to the 20th of March. And then for the summer solstice curve, you can draw the offset of the summer solstice curve relative to that straight line, and you can quantify the offsets like that. That's how Labilont set up his table, but you won't find values even remotely like that on his table, because he was using a different reference line, and he was also taking equation of time and azimuth and longitude reference relative to Stockholm into account. So enough of that. And I'm now going to have a more colorful version. This is still 60 degrees north. Now I've now got red for summer, blue for winter, and this sort of magenta color for the equinox. And let's see what happens if we start heading north. Here's 70 degrees. Well, unsurprisingly, things close up, and you'll see that I've only got these 2 sunset times. In the winter, the sun is never shining at 70 degrees north, and in the summer, it's shining all day. So there is no sunrise and sunset times except for the equinox. At 80 degrees north, all 3 are pretty much a straight line. You cannot, unfortunately, go right to the North Pole with this diagram, because azimuth has no meaning at the North Pole except for south. But at 89.999 degrees north, pretty close to the North Pole, just about a few hundred feet from it, it is very, very close to a straight line. So you might think, well, this compass has utility, certainly in the northern latitudes. Suppose we backtrack to 50 degrees north, which is just south of the United Kingdom, just north of Paris. And, well, my wristband could certainly work for this latitude, but we'll find that as we head towards the tropics, the thing becomes more and more unwieldy. Here we are at 40 degrees north. Well, I think my wristband could cope with that, but you need a wider wristband. Do notice also that the times of sunrise are much less varied than they were at further more northerly latitudes, just as you'd expect. Well, we're now still north of the tropics, but not by much. Let's go from 30 degrees to 23.44 degrees, which of course is the Tropic of Cancer. And you see an amazing thing happens here with the summer solstice line on the day of the summer solstice, which of course is the day when the declination is 23.44 degrees. In the morning, starts just before 6 o'clock. The sun doesn't move very much. It takes a long time, 6 hours to get to due east, and then precisely 0 hours to get from due east to due west. And then it slowly changes after that. So we have this instantaneous flip. And that's very disturbing. How can it possibly do that? Well, the answer, of course, is that at midday, it's directly overhead. And so the sun is actually still moving at its gentle 15 degrees an hour, but the azimuth is flipping, and it's very difficult to measure azimuth when the sun is very close to the zenith. Let's now go down into the tropics and see another strange anomaly. Here we are at 20 degrees north, and again, look at this summer solstice curve. At 6 o'clock, the sun is about east-northeast. It then moves towards the east and then backtracks. And we have an ambiguity. If you could measure east-northeast with your compass, you couldn't tell whether it was just before 6 o'clock in the morning or just before 12 o'clock midday. Of course, you'd know by where the sun is in its altitude. In short, azimuth sundials are completely useless at the equator. It's much better to use an altitude sundial. And here we are at 10 degrees, where this is more accentuated. It would be completely impossible to market this with a wristband. And at this latitude, your wrist would get very sweaty with a wristband anyway. And here we are on the equator itself. And here at the equinoxes, you see we're east all morning from midnight, when it's below the horizon, of course, at sunrise to 12 o'clock, it's absolutely due east, flips to due west, and then in the afternoon, it's due west until sunset, and it stays due west where you can't see it until midnight. Final example. Off the east coast of Malaysia is an island, Pulau Tioman. The Malay word for island is Pulau. 2.75 degrees north. And so supposing I was marketing this chart for that. As a matter of fact, this island is quite interesting because it is long north-south and short east-west. It's about 4 miles across at its finished point, at its midpoint, and it's almost all primary jungle. That there is a narrow jungle trail, which I've used, going from the west coast to the east coast. And when you're navigating in jungle, it's a very good idea not to get lost. You can use a compass, took a compass with me, but you can actually just use the sun. Watch, because all morning the sun is due east. And I was staying at a place on the west coast of the island. And so I just aimed at the sun all morning. You suddenly see glimpses across the trees. And of course, the altitude is getting higher and higher. So even when you were just looking up through the jungle canopy, you could see where the sun was. And you just head for the sun. And then you aim to get to the east coast near the middle of the day, where it's impossible to tell the direction of the sun because it's too close to the zenith. That's where you have your lunch break. Then in the afternoon, when you go home again, you just head for the sun again because it's due west. And so you don't need to know anything about the time. Or indeed, you don't need a compass or a clock. You can navigate yourself safely across through thick jungle and get back again. And that's a good place for me to stop. And I'm now going to unshare my screen and say that's more than enough for me. And I do hope some other people will take more parts. So, Martins, have you got any hands up?
Thank you very much for the for this analysis of this compass sundial. There are no raised hands, but I see two comments.
Yes.
Okay. One is that Jeff is saying that he has to leave the call, but there's another one. There's a reminder by Doug. Don't forget our conference next April and the usual appeal for speakers. Could Doug possibly comment on the key dates by when the topics should be submitted to the conference?
Is Doug hearing us?
Doug should be on call.
No, he's muted.
Here we are. I'm
Yep.
just looking on the calendar, and it's the 12th to the 14th of April in Peterborough, the cathedral city of Peterborough, in a smart hotel.
So these are the dates of the conference, but by when the talks should be submitted?
Are you not hearing me?
Yes.
You know,
Huh?
the question is by when participants should announce their talks. So what would be the topics for the conference?
What's your deadline?
Yeah, I mean, contact me for if you've got some suggestions for speakers.
Okay.
Do you have a deadline, a cut-off date?
No, I don't.
No.
I'm usually quite flexible on arranging for the speakers, and I'm happy to take people at the last minute, provided there's room in the programme.
Yes. Well, put me down for a talk. I have no idea what I'm going to talk about. I'll make something up by the time the conference comes. It's in Peterborough.
I'm sure you will.
Any other announcements, questions, comments, please? Julian, please.
I've seen her.
I just wanted to say to everybody, I've just seen Martin Skill's Sundial in Riga, an immense, elaborate and extremely sophisticated thing, design on the ground outside the railway station in Riga. And Martins, are you going to talk about that to us, or have you already done so?
I haven't planned to talk, but I could write a brief article for the bulletin.
At the conference, are you coming to the conference?
I'm not sure yet.
If you do, you can talk about it then.
There's some pictures of our visit, which I'm just holding up. And there are two figures on the ground, and there is a notice board about well, Martins, what is it about? It's about
this is a sort of a design object, and also it shows directions and distances to castles in the Baltic region, and also to some major cities. And I'm happy that you managed to visit, but unfortunately we didn't have the chance to meet, as our schedules quite didn't match.
We will one day, but I think an account of your sundial, a description with proper pictures, would be of interest to everybody.
Okay.
And secondly, there is an immense vertical gnomon dial on the land spit in just off Lithuania. There's a spit of land, and there's an immense sundial on the what's you know the name, I'm sure, but that needs a complete thorough write-up by somebody.
Is that on the spit and on the border, almost out to sea?
There's a spit of land it belongs to Lithuania, and it runs down to the border with Russian enclave.
The place is Nida, I think it's called.
The village is Nida, and the sundial. I can put It's got its own name, but I don't know who designed it. It's been there for about 20 years or more, but it needs a write-up. It's a very interesting dial.
I have some information about that sundial, and I could try to write it, and then you could be a co-author for the article. Yeah.
Yes, I am not capable of doing it, but an expert does need to describe it.
Thank you. Any other comments or questions?
I think we can let people go to have their breakfast, lunch, or dinner if ever is the case.
To summarize, there were 30 participants at the peak moment in our call. I think it was very good.
Yes, that's about the right number. One day I may increase it, but until we've learned how to handle it, until there are more people willing to speak, I will stick to this. So thank you very much, everybody, for your attention. And thank you even more if you participated. And we very much look forward to seeing you for the January equivalent and then the April conference, when there will be another one of these after the conference, I suspect.